continue with our idea of functions. We're looking at some graphs of functions. So P6, we're looking at the vertical line test. If you're using the vertical line test, that's a test to test if something, if a graph is actually a function. So we use the vertical line test in most cases only when we have the graph. There would be no reason to use it in any other particular situation. So the vertical line test says that if I draw a vertical line, one of two things happens. Either I get a function, or I don't. I get a function when I draw that vertical line, and it only touches one time. I get not a function when it touches more than one time. And maybe I should change the word to from touches to crosses. That probably is a better representation of what we're going to be looking at here. But if you use touches, that's all right too. So when I'm looking at the vertical line test in example A, I'm going to draw a vertical line. Okay. So I draw a vertical line, and the vertical line touched this graph at only one place. Okay. As long as I can go on this whole graph anywhere that I want to and draw a vertical line and it touches in only one place, then I have a function. And so if I were to take this line and I were to move it, if I were to move it to the left or I were to move it to the right, it's only going to touch that graph in one place. It's not the same place, but it touches it only in one place. And so this is going to be a function. If I were to take that same vertical line and I were to come over here to this oval shape, I'm going to follow along with that vertical line, and we can already clearly see that this is touching in two different places, right here and right here. Okay. It's already touching in two places. Anytime that happens, then this becomes not a function. Taking a look at example C, let's see if we can grab this line here. It's not going to let me grab the line, so we'll draw a new one. That's not a very good one. Well, let's try this line. Alright, there's our vertical line. So we're going to grab this vertical line and we're going to move it along this graph. And I can see that, again, it's only touching one place, one place, one place. This whole way across, it's touching in one place until I get to right there. When I'm right there, that has a vertical portion to it, and it's touching this whole time. This whole section is touching on this graph. So this is not a function. Anytime that it touches more than once, it's not a function. So I'm going to try to take that line again, bring it over to this one. And again, I'm following along, going the whole way. As you can hopefully see, continues to touch only in one place, and so this is a function. So the last part of this section is just evaluating numbers, plugging numbers in. So I've got a function f of x, and I'm evaluating, for part A, I'm evaluating f of 2. So I've got f of 2 is equal to negative 2 squared minus 3 times 2, which is negative 4 minus 6, which is negative 10. Be careful with that negative. It's not negative 2 squared, like negative 2 times negative 2. It's the opposite of 2 squared, which is negative 4. The next one, f of 0, I'm going to plug in a 0, so I've got negative 0 squared minus 3 times 0. Well, negative 0 and 0 squared don't mean really a whole lot. 3 times 0 is 0, and so I end up with a 0. F of 0 is 0. F of negative 3, again, be careful with those negatives. We get a negative 9, and then negative 3 times negative 3 is plus 9. Add those two together, negative 0 as well. And then finally, plugging in 1/2. When I do 1/2 squared, I get 1/4, so I get negative 1/4. And then 3 times 1/2 is 3/2. In order to add these together, I need a common denominator. So I'm going to multiply both top and bottom of the second one by 2. So I get negative 1/4 minus 6/4. Negative 1/4 minus 6/4 is negative 7/4. I end up with negative 7/4. So that should be a 4. And then the very last part here, use the graph of y equals f of x. So you're given a function, here's the graph of it, and you should find the indicated values. So this f of negative 7 means that I'm looking at the f function at x equal to negative 7. And I want to find out, what does y equal? That's really the question. So I go to negative 7. Negative 7 for x is way over here. And I want to find out not where that value is, but I want to find out where does that correspond to the y value. And it corresponds down here, down at negative 4. So that's the question what they're looking for, is what does y equal? So f of negative 5. Negative 5 is right here. I want to know what the y value is. The y value is equal to 0. F of negative 3. I go here and I follow down. Yeah, the point's right here at negative 2. F of negative 2. Follow that down. That's also at negative 2. F of 0. Follow that down. Look at that. At negative 2. F of 2. Follow that down. Well, since we're still on this straight line, we still have a negative 2. F of 4. Nice little change of pace. We're estimating on this one, it's going to be roughly negative 2.5. We don't have the function to be able to plug that in, and so we're estimating on that last one. F of 5, we're going to follow that down. It's down here at negative 3. F of 6, follow that down. It's way down here at negative 5. And finally, negative 7, actually goes up here, is up here at 2. And that's using the graph in order to find out the function values and plugging in numbers to evaluate the function values.